All right, Algebra 1, Lesson 12.7, Solving Rational Equations. So please, I keep asking you guys, please try the warm-up before you sit and watch me do it, just to see if you can make sure you know what you're doing. All right, so if you could pause the video and do this. So part 1 says to find the LCM, which LCM is the least common multiple, so meaning the value that all three of these terms can be divided into. So to get the number part, we look at all the numbers. So we've got a 1 out in front here, even though it's not written, a 2 and a 6. So the least common multiple of 1, 6, and 2, meaning the number they all can be divided into, is 6. 6 goes into 6, 2 goes into 6, and 1 goes into 6. And then we look at the variables, and we list our variables since there's only x's, and we use the bigger of the exponents. So we use 6x squared. So that's our least common multiple. All right, on this next one, we need to factor both first before we decide what our least common multiple is. So I think it's 4, p plus 4. So this first one I could pull out a p, and the second one's a perfect square binomial. So basically what you're doing is, in order to get your least common multiple, you're including every factor, okay? So I would take, I know that I need a p minus 4. That needs to be part of it. Since this has a p plus 4, I need a p plus 4. And since this side has a p, I need a p. So my least common multiple are basically all of them combined, but I only need one of the p minus 4 since each one only had 1. Okay, next part says to multiply and simplify. So I'm going to multiply across. So 5 times 2 is 10. X squared times x is x to the third. And then 3y times 7 is 21y. And there's nothing I can simplify. All right, this next one, this we can write over 1, remember? And I'm actually going to factor this first, and it's a perfect square binomial. So I'm going to do, or the sum and difference of 2 squares, I guess, or say it that way. So now that I factor it, I can cancel these, and I get 4 times x minus 3 over 1. And I don't need the 1, and I can distribute this, so I get 4x minus 12. And that's my answer. All right, on this next one, kind of the same thing. I'm going to factor, I'm going to erase this so I can write above this one. I'm going to factor first before I try to multiply. So this is a trinomial that on top, the x squared minus x minus 30, that I can factor as x minus 6 and x plus 5. All right. Down here, I'm going to pull out a 4, and then I'm going to factor. So after I pull out a 4, I get x minus 6 and x plus 1. And then up here, it's a perfect square binomial that I can factor as x minus 1 and x plus 1. So now I've got a whole lot going on here. I'm going to draw like a line so you guys can tell that this is all part of this problem. Okay. So this x minus 6 can cancel with this x minus 6 because they're diagonal. This x minus 1 can cancel with one of these x minus 1s. And then this, because it's right above it, I can cancel the x plus 1 and the x plus 1. So we can cancel diagonally or right above. And just a reminder, that's only when there's a multiplication. You can't do this with addition and subtraction, so pay attention to your signs. So on the top, we've got this x plus 5 left, and on the bottom, we've got this 4. So our answer is x plus 5 over 4. So in this lesson, we're looking at solving rational equations now. So we're actually solving for values, and we need to know how to identify extraneous solutions. And then the term rational equation is what we're going to come up with. So we've talked about a rational expression. Now a rational equation is just an equation that contains one or more rational expressions. So an equation, remember, is anything with an equal sign. And if a rational equation is proportion, we can solve it by cross multiplying. And I think we've talked about this before, so it shouldn't be anything too new. Okay, so solving our rational equations, meaning when we have an equal sign, we can do something called cross multiplication. And what that means is I take basically what's diagonal and I multiply it. So it would be 3 times x minus 2 and we use an equal sign, then this diagonal, 5 times x, which is 5x. Now I'm going to distribute, so I get 3x minus 6 equals 5x. Move my 3x over, so I get negative 6 equals 2x. Divide by 2, and x is equal to negative 3. Now we should check our solution. So that means plug in the negative 3 into your original x. So 5 over negative 5 equals 3 over negative 3. And it does because 5 over negative 5 is negative 1, and 3 over negative 3 is negative 1. So that works. So this is a good solution. All right, so if you guys could, go ahead and pause and try to do this one, okay? So I want you to go ahead and pause it right here and see if you can do this. All right, so because we have an equal sign, we're going to do the cross multiplication. So I'm going to take 3 times n, which is 3n, equals 1, and since the 1 does technically get distributed to the n plus 4, I mean 1 times anything is the other number, so we just have an n plus 4. I can move that n over, so I get 2n equals 4, divide by 2, and n is equal to 2. I should check my solution, so I'm going to plug 2 in for n, equals 3 over 2 plus 4. I get 1 over 2 equals 3 over 6, and 3 over 6 is 1/2, so we're good. Some rational equations contain sums or differences as part of the rational expression. So to solve these, you have to find the LCD, which stands for the least common denominator, of all the rational expressions in the equation. So let me show you. So finding the least common denominator is not going away. So this equation, we have an equal sign. We can't do cross multiplication because there's a plus sign right here. I mean, until we get rid of that plus sign, we can't do cross multiplication. So we need to figure out the least common denominator. And the way we do that is to include every factor of the denominator. So here's a denominator, so there's part of it, x plus 1. Here's part of it, so an x. And then we have another part, which is 2x. So we actually only need to include just a 2x. We don't need to do a 2x squared. We just need a 2x since there's already an x in these two. Okay? So those are all factors because x can go into this. So that's why we only need 1x. Now you're going to take that least common denominator and multiply it by everything in the equation. So we're going to take 2x times x plus 1 times 2 over x plus 1, because that's this first part, plus 2x times x plus 1 times 3 over x. So we're multiplying it by each part, equals 2x times x plus 1 times 5 over 2x. The reason we're doing this, you guys, that we're multiplying it by every part by the least common denominator, is we're getting rid of our denominators, so we don't have to have them, so that makes things a lot simpler. So when I do this first part, and I can put it over 1, so you're allowed to do that. If I take 2x times x plus 1 times 2 over x plus 1, I can cancel these, and I'm just left with 2 times 2x, which will give me 4x. Over here, I can cancel this x with this x, so I'm left with 2 times 3, which is 6, times x plus 1. So I've got that right there. Equals this 2x and this 2x will cancel, so I'm left with the 5 times the x plus 1. Now I'm going to distribute. So this becomes 6x plus 6 equals 5x plus 5. Okay? That makes life a lot easier because if I recopy that, 4x plus 6x plus 6 equals 5x plus 5. I can combine like terms, so I get 10x plus 6 equals 5x plus 5. Move my 5x over. I get 5x plus 6 equals 5. Move my 6 over. And now I can just divide by 5. So my answer is negative 1/5. So the big hard part in this is that you have to, you're basically getting rid of your denominators, okay? So you don't even have to actually use cross multiplication. You're getting rid of your denominators So in that sense, you're going to end up with a normal equation. So that makes life a lot easier. Okay, so let's look at another example. So we do have an equal sign, so it is an equation, but we can't do cross multiplication since there's a minus sign on this side. We have to find the least common denominator, and in this case, because we have an x and an x squared, it's an x squared. So if you think about that, if I multiplied every part of this equation by x squared, or you can think of it as x squared over 1, that would allow me to have this x cancel with that. So I've got an x times 4, which is 4x. These would cancel, so I'm just left with a minus 3. And then 1 times x squared is equal to x squared. So I was able to get rid of all my denominators. Now here's where I see you guys mess up. When you see an x squared and an x, and then another term with no x, you can create a trinomial. So I can move these over. So I get 0 on one side, and I like to move them this way so my x squared stays positive. Now I'm going to have a minus 4x and a positive 3. This can be factored so that I have two solutions. So I'm going to have a 3 and a 1, and I know that I need a negative and a negative. So my solutions then, I set these equal to 0 using our 0 factor property. I get an x equals 3 and an x equals 1. Okay? Now you should check both your answers. So I should check them individually. So you have to check them separately. So if I plugged 4 over 3, so if I plugged 3 in to x, so I'm only going to plug 3 in, I would get 4 over 3 minus 3 over 9 equals 1. So I want to see, okay, 4 over 3, I can simplify this. I'm going to make this a 3. So 3 goes into here, 1. So I get, sorry, there should be a minus sign, 1 over 3, which equals 1. 4 minus 1, because I have a common denominator, is 3 over 3. So 3 over 3 is 1, so that's a solution. You also should check the other solution. So I'm going to plug a 1 in. So 4 over 1 minus 3 over 1 squared equals 1. Anything 4 over 1 minus 3 over 1, because 1 squared is 1, that just becomes 4 minus 3, which is 4 minus 3 is 1. So this is a solution as well. So let's review. I found the least common denominator. I multiplied every part by that least common denominator so I could cancel my denominators out, and I'm left with a simple expression. A reminder, when you see a squared term, you're probably going to want to make a trinomial that you can factor by your guess and check and get two solutions. And then you need to check those two solutions to make sure neither one is extraneous, or maybe one of them is. All right, let's try this again. I do this time have an equal sign, so I could do cross multiplication. That's okay. So we're going to, because I don't have a plus or minus on this side, so I'm going to take 2 times x squared minus 1 equals x plus 1 times x minus 6. This I can distribute, so I get 2x squared minus 2 equals, I'm going to FOIL, so I'm going to get x squared. I know that my middle is going to be a minus 5x, and then I'm going to have a negative 6. Now I'm going to combine like terms. I'm going to move this x squared over, so I get x squared minus 2 equals negative 5x minus 6. I'm going to move my 5x over and my 6, so 5x and 6. So I get x squared. I can combine this plus 5x plus 4 equals 0. I can factor now. Okay, I know I need a 4 and a 1, and I need them both to be positive signs. So my solutions are x equals negative 4 and x equals negative 1. All right, before I say that those are specifically the answers, I need to check if either one is extraneous. So what that means is I have to check them both individually. You don't plug the 4 into one x and the 1 into the other x. You have to do them separately. So I'm going to check x equals negative 4, and over here I'm going to check x equals negative 1. So if I plug negative 4 in, I'm going to get 2 over negative 4 plus 1 on this side equals negative 4 minus 6 over negative 4 squared minus 1. So that becomes 2 over negative 3. I'll get a negative 10 on top. Negative 4 squared is 16, and then 16 minus 1 is 15. So let's move that down. I can simplify 10 and 15. 5, I can go into both of them. So 5 goes into 10 2 times, and 5 goes into this 3 times. So I get a negative 2/3. So that one is okay. So x equals negative 4 is good. Let's plug in the negative 1. So 2 over negative 1 plus 1. And on this side, I plug in the negative 1 to x over negative 1 squared minus 1. So negative 1 plus 1 is 0 on the bottom. And then I have a negative 7 over negative 1 squared is 1. And then 1 minus 1 is 0. Well, can we have a 0 on the bottom of the denominator? No. So this is not a solution. So the only solution is negative 4. Negative 1 is extraneous. It doesn't work. Okay? So just to review, if you have an equal sign, okay, you can simply cross multiply as long as there's no plus or minuses on either side. When you have a plus or minus on one of the sides, so for example, there's a minus here, you need to multiply every component by the least common denominator so that you can get rid of all your denominators and just have a simple equation to solve. And then the other thing I'm seeing issues on is when you guys have an x squared term, you want to collect everything on one side and set it equal to 0 so that you can factor it and use your zero factor property. Okay? So that is all.